Myself Padmaja, Associate Professor, Department of CSE, Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss about algorithms and flowcharts. Now, first discuss about what is an algorithm and what are the properties of an algorithm. Now, coming to the definition of algorithm, an algorithm is a finite sequence of instructions, each of which has a clear meaning and can be performed with a finite amount of effort in a finite length of time. Now, if you will see this definition, there are four important points over here or key points over here. One is called every algorithm must have finite sequence of instructions. That means whenever you write an algorithm, you should not write in infinite number of statements. Then, which should have a clear meaning. That means every statement in the algorithm must have some definite or clear meaning. There should not be any ambiguity. Third point is that algorithm should be performed with a finite amount of effort. That means the execution time, whenever you will implement that algorithm, it must have a finite amount of time and finite amount of effort is required to complete the application. Now, let us understand what are the properties of writing a good algorithm. So, first property is called input, second one is called output. Now, input and output are the basic properties because whenever you write an algorithm, every algorithm must take 0 or more inputs and the algorithm must provide some output as a solution to the problem. So, input and output are the mandatory steps for any algorithm. So, you should give some input to the algorithm and you should expect some solution or output for the problem. Now, apart from this input and output, we can have definiteness, finiteness and effectiveness as the properties. Now, what is definiteness? Now, definiteness property says that all the steps of the algorithm must be precisely defined. Okay. Then finiteness says that for any input, the algorithm must terminate after executing a finite number of steps. So, it should not go into an infinite mode. Then effectiveness, it says that whenever you execute an algorithm, it must be possible that each step of the algorithm must be correctly written and it should take a finite amount of time. You should not write any complex or tricky statements in an algorithm so that you will take additional steps again to understand each step. So, this is called the effectiveness property of an algorithm. So, after knowing about the algorithm and its type, now let us understand what are the practical design issues whenever you design an algorithm. Now, choosing an efficient algorithm or a data structure is an important criteria for any application. Now, there are three basic design goals are there. We should always be careful about these three things whenever you are choosing or writing an efficient algorithm. First of all, you have to try to save the time, that is called time complexity. Then try to save the space, that is the memory space, that is called space complexity, and try to have phase. So, these are the three design issues for writing an effective and efficient algorithm. Now, if you will find out what is the performance of a program or algorithm, then it is measured in terms of two parameters. One is called the time complexity, other one is called the space complexity. So, time complexity is nothing but the amount of time required by an algorithm for the execution. So, the time needed by an algorithm is expressed as a function of size of the problem. Okay, and the size of the problem or the input size of the problem is the main criteria for computing the time complexity. You can simply say that the amount of computer time required for the computer or for the CPU to execute the algorithm until the completion of it. So, this is called the time complexity. Then next is called space complexity. So, it is nothing but the amount of computer space required for the completion of the algorithm. Now, what are the different types of space requirement for an algorithm? One is called an algorithm contains a number of instructions or statements. So, we need some instruction space. Second type of space requirement is every algorithm must have some variables, a number of your variables or constants may be there. So, the data values which is used in that algorithm must be stored. So, it requires some data space also. And the third one is that the algorithm may need some stack memory also. So, the environmental stack space is also required. So, the memory space, whenever you are computing how much memory space complexity is required, then you have to keep all these things together. You have to add all these memory requirements together to compute the total space requirement for the algorithm. Now, if you will learn about time and space complexity, then out of these two things, the time complexity is an important parameter for measuring the performance of an algorithm. So, based on the time complexity, the problems are divided into different categories. One is called constant running time. Certain applications are there which requires constant running time, that is called your big O of 1, order of 1. Then certain applications require log n time complexity, which are by default logarithmic in nature. So, it is big O of log n. Then certain applications require n, that is your linear time complexity. So, it is order of n. Similarly, order of n log n square, n cube, 2 to the power of n, n to the power of k. These are the different time complexities that we have to find it out. Now, what are the different criterias which are taken care whenever computing the time complexity? So, if one thing is that time complexity is a function of f of n, where n is nothing but the input size. But apart from input size, for different types of application, the n will be different. So, let us understand what will be the type of n value. So, n is basically the number of data items to be processed. Now, in some applications, n may not be a number of data items. N can be a degree of polynomial also. If you are doing some mathematical application, n can be degree of polynomial also. N can be the size of the file also. If you are doing a file processing application, then the time complexity is required on or calculated based on the size of the file needs to be processed. So, n can be the size of the file. Okay? Or n can be the number of nodes in a graph. If you are doing a graphical application, then if you are reading a graph and doing some applications on the graph, then n can be the number of nodes in the graph also. Now, so we'll come to complexity of algorithms. So, the complexity of the algorithm M is a function of f of n. So, where n can be anything, it can be number of data items, or it can be the degree of polynomial, or it can be the size of the file, depends on the application. So, which gives the runtime and the storage space requirement of the algorithm in terms of size of n. So, by combining these two things together, time complexity and also space complexity, the total complexity of an algorithm M is computed. Now the function f of n gives the runtime of an algorithm mostly and depends not only the size of the input data but also the other particulars of the data. So, the function f of n is computed based on certain parameters. So, the time complexity we have to compute based on the lower bound, upper bound and the middle bound. So, based on that, we have three types of cases. One is called the best case, one is called average case and one is called the worst case. So, the worst case always gives the upper bound on the runtime. But the average case provides the tight bound or expected runtime. And the best case always gives the lower bound on the runtime. So, this way the time complexity is divided into these three cases and it is computed. Now, we discussed so far what is an algorithm, properties of an algorithm, followed by we discuss about time and space complexities. Now, come to flowchart. So, what is in flowchart? So, coming to flowchart, a flowchart is a pictorial representation of an algorithm. Simply you can say like this. So a flowchart is a type of diagram which represents a workflow or a process. Now a flowchart can also be defined as a diagrammatic representation of an algorithm or a step-by-step representation for solving a task pictorially. So there are multiple definition you can say for an algorithm. So at least you can understand that a flowchart requires a number of symbols to understand the step-by-step process of solving a task. So the flowchart consists of a number of symbols. So the flowcharts can be used for multiple purposes also. One is called, you can use flowcharts for analyzing a problem, for designing a problem, for documenting a problem, or for managing a process or program. So in various applications, flowcharts may be useful. Now let us discuss about what are the symbols popularly used in a flowchart and how to write a flowchart. Now, what are the symbols used in a flowchart and what is the name of the symbol and what is the purpose of each symbol? Let us understand in this slide. So, suppose we have a symbol called oval. Now, this symbol is used to represent the start and stop process of the flowchart. That means where you have begin the flowchart and where you are ending. To represent the start and stop, we are using oval. The next symbol is called parallelogram. This particular symbol is used for indicating the input and output operation, because in every algorithm or flowchart, you have to read some input and you have to present some output after processing. So, for reading the input and for displaying the output, this parallelogram symbol is useful. Then, the third symbol is called the rectangle. This symbol is used for doing any processing application. Like any application can have some mathematical statements or arithmetic operation to process or some data manipulation you have to do. So any kind of processing statements you want to write, you need to use this rectangular box. Then next symbol is called a decision box. So this particular box is used for decision making. Okay. So if you have more than two alternatives, then you can use this decision box, or in cases of true and false kind of decision you have to make, then binary decision you have to make, you can also use this decision box. Now, whenever you write any flow diagram like a flow chart, then these are the different types of arrows which are very popularly used to indicate the direction of flow. So, up arrow, down arrow, left and right arrow, these are the four types of flow lines that can be used in a flow chart to indicate the direction of data flow or information flow. Then we are using a small circle which will be used as a page connector. Suppose your flow chart, the length of the flow chart is more than one page or two pages, then you have to connect the flow chart through a page connector. Then followed by the off page connector, you can use this. So if you want to write a function or a predefined process, then you can use this symbol. Then for a preprocessor, you can use this symbol, and for comments, you can use this symbol. So there are a number of symbols available, and using these symbols, you need to write a flowchart. Now, let us understand one small problem, that how to write an algorithm and flowchart for finding the largest of three numbers. Now, so for finding the largest of three numbers, so if you talk about the algorithm, first we should understand what is the input. So input is nothing but we need three numbers. Three numbers, A, B, C, for example, or some values you can take. So we need to read the three numbers. And what is the output? So the output is, we have to tell that which number is the biggest number or largest number we have to tell. So this is the output. Now, keeping these two things in mind, we need to understand what are the processing steps. So first understand the algorithm. So we are starting the algorithm by writing start. Then we have to read the input by read three numbers A, B, C or some values. Then we have to write down the logic for it. So how to compare? Suppose you have three numbers, then compare the first number with second and third. So if the first number is bigger than second and third, then first number itself is the largest number. So same logic I have written over here. If A is greater than B and A is greater than C, that means A I am comparing with B and C. Then if A is bigger than both B and C, then print A is largest. So if this is not true, then go for the second criteria, that you compare B with C and A, and you say that if B is greater than C and also B is greater than A, then you say that B is largest. So if both of the conditions are false, then automatically C is the largest number. So this is the simple algorithm, and after this we are stopping. So if you see the properties of algorithm, input output properties it is satisfied. Then you have the property of called finiteness. So here finiteness property it is satisfied. So it has only 4 statements. So finite number of steps are there. Then definiteness. So you can see here it has each statement has a clear meaning and it is written precisely. So it is an effective algorithm. Yes, it is an effective algorithm. So effectiveness is also there. So these are the properties it is following. Now let us convert this algorithm into a pictorial representation, that is called a flowchart. Now, so for drawing a flowchart, we have to use the flowchart symbol. So for start we are using oval, for stop we are using oval. Then we have to read the input. So for we are using parallelogram. Okay, parallelogram we are using. Then after reading these 3 numbers A, B, C, then you have to compare. So for that we are using a decision box. So if A is greater than B, if it is true, then you are comparing is A is greater than C. So these 2 criteria we can write in a single box or we can write separately. So if A is greater than B is true, then check whether A is greater than C. If both are true, then print A is the largest number. Okay. Suppose A is not greater than B, then if it is not true, then check B is greater than C. If it is yes, then print B is the largest number. Like that, all the criteria you have to check and by writing the decision box as yes or no. And finally, you will get your largest number which you are printing. So for input and output, we are using the same parallelogram. And once the process is completed, we are just stopping it. So this is called an flowchart for this problem. Now, these flowcharts are also used for different types of other statement, like for simple if, for if else, for switch case, and so on. We can also draw the flowcharts. So what is a simple if? Simple if that there is one condition or expression. If that expression is true, then what you have to do? If that expression is not true or false, then you have to do nothing. That is called a simple if. So you can see here start and stop symbols are there. Then we are checking the expression or condition. If this expression is true, then we are executing some statements. If it is false, then we are doing nothing and we are coming to the end. Similarly, we have if else. Now in this if else, you have 2 options. That apart from start and stop, in the condition you have 2 options. If it is true, then do something. If it is false, then do something else. So this way a flowchart is drawn for if else. Similarly, when you have multiple alternatives, then you have to go for a switch case statement. So you have to write down one expression. The expression may have multiple options. So if it is satisfying the case 1, then you have to execute a set of statements. If it is not satisfying case 1, then check for case 2. Then you have to execute another set of statements. If it is satisfying case 3, then you have to execute another set of statement. Like that, it can have multiple number of alternatives. So if none of these cases are true, then you have to execute the default one, and the default statements you have to execute. So this is called a switch case expression, and this is the flow diagram for switch case. Similarly, flowcharts can also be used for representing different types of loops. So what is a loop? Loop is a repetitive statement, a block of code which is repeatedly executed until a particular condition is false. So for writing the different types of loops also, flowcharts are used. So you can see here for the for loop, for start value, then the for loop has 3 parts. For loop has 3 parts. One is called initialization. Second part is called the condition. And third part is called reevaluation. And then you will have the body of the loop. Now, coming to this, first we are doing initialization. Suppose here we are declaring some counter or some variable with some value. So this is called initialization. Then we have to do the condition checking here in the evaluate condition part. If the condition is true, then we will execute some statements. Then this part is called reevaluation. And then again we will check the condition. So this process will be repeated until this condition is true. But when this condition becomes false, it will stop the loop. So next is while loop. So in a while loop, we write like this. The pseudocode is while condition. So if this condition is true, then we will execute a block of statements. If this condition becomes false, then we will come out of the loop. So this while loop is called entry control loop. That means the entry condition is tested. If it is true, then only it will execute the body of the loop, otherwise not. So you can see here, we have started. Then we are evaluating a condition first. So if this is true, then execute the statements and repeat, and second time you evaluate the condition again. So the block of statements are repeatedly executed and conditions are evaluated until the condition becomes false. So when the condition is false, it is coming out of the loop and it will stop it. Then the third type of loop is called your do while loop. In the do while loop, we write the pseudocode like this: do a set of statements, and at the exit we check the condition, while condition. Now in this, at least the block of code is executed once, and at the end of that we will test the condition. If the condition is true, then we'll repeat the code again. If the condition becomes false, it will come out of the loop. Now let us see over here in this flowchart. So first start, then we are executing a set of statements. Then we are evaluating a condition. If the condition is true, then again go and execute repeatedly the set of statements. So every time after executing the set of statements, the condition is evaluated until the condition becomes false. This process will be repeated. When the condition is false, it will stop the loop. So for representing the different types of loops also, flowcharts are popularly used. Thank you. In this video, we have learned about what is an algorithm and what is a flowchart, and followed by the problem we have written, the one application we have written, how to represent it through an algorithm and flowchart. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.